And I don't know whether it's coincidence, I keep getting the just pre-coffee sessions. So hopefully the energy sector energy should be reflecting in the audience. So I'll be touching on the IEC61508 mostly as an overview, and probably put more emphasis on the V&V part. And since morning, especially in the energy the track, all the speakers have been touching upon the 61508. They are making passing reference. So we'll slightly go more detail into this. That's the agenda. So oak systems since 1998, so which means we just turned 18, and we have been into specialized V&V services for various sectors. Yeah, some of the relevant sectors or domains have been listed here. So there are services being provided in other than these sectors too, and the type of services and the relevant standards are listed over here. Yeah, and as I said, we just turned 18, and we are getting engaged also immediately after turning 18. So we are going to be part of the LCCs. So, and the two rings that are there is one for the training and one for the V&V services. So it's going to be a complete picture as far as our engagement is there. Yeah, starting with 61508. So this is the overview of the 61508 as a whole. So it covers right from the concept to decommissioning. So it covers the entire gamut of operations, but mainly from the safety perspective. So don't mix this with the regular process expectations that are there. It could be from your CMMI or anything else equivalent ones. So this covers exclusively for the functional safety part, and we will be dealing specifically with the part 3, which is the software or the implementation. Yeah, going in detail. So that is the big picture, and within that there is what is called as a safety cycle. So what you need to be doing for safety cycle for the particular product. So that is again listed here. The figure may not be clear. We'll go into detail for the next one. Yeah. So this is very specifically for the realization part, the part 3 of the IEC 61508, and here again it covers from the planning to the 4 or 5 critical technical aspects: the requirements, the design, the implementation, and the validation. So those are the areas that it will cover as far as the realization is concerned. Few key terms before we proceed. So safety means freedom from something which is unwanted, okay, which is happening unexpected. So that is the safety loose definition over here. Functional safety is that it depends on a system or equipment operating correctly in response to its inputs. So there is a safety and there is a safety function, and then safety functional requirements, what the function is supposed to do, and these details are coming from the hazard analysis. Once you do the hazard analysis, it throws up some aspects of something might go wrong in that, and how to take care of that will define the safety function requirements. Whatever you do to take care of those hazards, to minimize or reduce or eliminate, so those become the safety function requirements. And safety integrity requirement is coming from what if those things don't work. So if there is a risk, if some of those safety functions don't work, so that is going to define your safety integrity levels. So eventually, so that comes from the risk assessment. I know I have planned for something to take care of the hazard, and what if they don't work? So you have to do the risk analysis and results in safety integrity requirements. Yeah, like many other functional safety standards, this one also has got 4 levels of SIL, 4 being highest and 1 being lowest, and the numbers that is shown here is the PFDs, the probability of failure on demand, and this very specifically refers to when a safety function is expected to perform and if it is not performing. So which means when it is not expected, if it is not performing, it is okay for us, because anyway we are not expecting the safety function to kick in. But this number is very specifically aimed at when a safety function is supposed to kick in and it is not kicking in, or it is not coming into picture. So those are the numbers, and as you see, the numbers are quite stringent, right from 1 to 4 over there. Again, this is depending on the hazard analysis again. So the SIL level for a particular product is arrived at as a consequence of your HAZOP, the hazard analysis, followed by FMEA and the risk analysis. All of them will put together will give the SIL number for the product, and those product level SIL requirements and what needs to be taken care as a functional safety will now start flowing into the hardware and the software. So, there is something that is likely to go wrong at system level. Obviously, something has to be taken care, and it can be taken care either by the hardware or by the software or by the combination of the two. Eventually, those things have to be met, and that way the assignments of the requirements will happen to either software or the hardware or the combination. Yeah, as you start now developing, so you go through the requirements phase. So, there is a structured representation. Very specifically, the 61508 talks of what is called as the formal methods, which means you may have to develop your requirements or define your requirements as a formal methods, which might include mathematical modeling, which means flowchart is again not considered as a formal method, or a modeling also is not considered as a formal method, which means you may not give precise numbers when you are doing modeling, but when you are doing mathematical representation, it is supposed to come with precise numbers to be defined. If this is the input, this has to be the output. So, it lays emphasis, the 61508 lays emphasis on the formal methods, especially for SIL 4 kind of a requirements, SIL 4 expectations. And then there are some semi formal representations. So, that includes your truth table, decision tables, your flowcharts, and even MBD part also. Yeah, and of course, including the computer aided documentation tools for the MBD architectures. So, here again you define what should happen as part of the diagnostics, what should happen if the diagnostics detect a failure, how the failure has to be recorded, and what reactions have to be done for that, what conciliatory action has to be done, and whether the system has to be taken to safe state, or should be fail safe or fail operational, depending on the type of fault it detects. So, all those things will get defined in the requirements. Coming to the design and development, so again follow through the structured design. If at all you have using the library components, again proven in use kind of a design components are there, go ahead and use that, and the usual design methods you go through that. And what I mean by FMEA, sorry. Yeah, this FMEA and fault tree analysis is again can be done separately for the software part. You have done the system FMEA or system HAZOP, you may have to do the FMEA and HAZOP even for the software also. And what is the meaning of FMEA for software is, what is the guarantee that whatever you are thinking as a logic is going to work accordingly in the microcontroller? There is no guarantee. So, if your FMEA is throwing that something might go wrong in the microcontroller, then obviously you have to take care of even that also. So, there is a system level requirements and given to the software, and while implementing the software, when you are doing the design and implementation of software, that itself will throw its different challenges. So, there are system challenges which are again passed on to the software. For software design and implementation, there can be additional challenges, and those have to be done for FMEA and fault tree analysis and corresponding reactions for that for the software part. Yeah, and some of these tools again Hanumanth has been mentioning about the programming languages, the strongly typed programming languages, or any standards and guidelines like MISRA may have to be employed. So, that is all given as part of the 61508 requirements. Defensive programming again is another from a safety perspective, defensive programming is another well accepted method. It also lays emphasis on the tools. So, what happens if when I am using a tool? So, the tools could be anything, right from your simple text editor that you are writing your requirements document, or your code itself. Code may be coming through the IDE part. Lot of or most of the compilers now come with an IDE. So, or it could be your testing tools, or it could be your testing automation tools, or simple measurement tools also. So, any tool that is being used in this product or the software development may have to be qualified before you apply that, or show that no, they are all proven. So, usually the tools can come from in-house, so which means we have developed our own tools, maybe as part of this project itself, or maybe some other department within the project, within the organization. It could be COTS, or we have asked a vendor to develop a tool for us to be used in this particular project, or it could be any other tool coming from the open source. So, the moment that tool has got a application in my activity, first thing is they have to be classified, So the 61508 gives two types of classification, online, or it's also called as on the fly or offline. So on the fly is something which will impact the performance of the software when it is running. So it is making a clear differentiation between a tool which is used and it affects the performance of the system or the software when the software is running. So typically it points to a couple of tools only where I am trying to configure on the fly. So I am setting some parameters when the software is running, so that I want a different performance or a changed behavior, and what if that is going to result in a hazardous situation. Okay. So if you are using that kind of a tools wherein you are trying to modify some parameters of the system when the system is running, so those are classified as on the fly or online tools. Your offline tools are the rest of them, which means I am not using them when the software is running, and on the software I am not going to use. It could start with your simple text editor, as I was telling, or it could be your documentation kind of a tools, or the highest one in that is called as T3, which is your compiler itself. Okay. My bad performance of a compiler, depending on the optimized setting, can really impact the functionality, but it is offline. I am not going to change the parameters or the code online. So the code changes offline, the compiler comes into picture offline. It may generate a wrong code or a most optimized code which is actually not performing what I want it to do. Okay, that's what happens with the compiler optimized settings. You never know, you are never guaranteed. You want a packed code to be generated, you want to set it to the maximum number, but then it is not generating the functionality which I want the system to be doing. So those are the tools which are classified as offline tools. So either of them, if you are going to use in your system, they have to go through the qualification process. Okay, which means if I have to use them, they have to be qualified, and the meaning of qualification here is, are they fit to be used in my project and whether it can take care of my safety requirements. Eventually the whole thing is pointing to the safety expectations. So the qualification could come from what is the process followed for developing the tool, whether that process has been following 61508 standards, or it has been proven in use. Maybe my company has been using that for the last 10 years, okay, and it has not not given any issues so far, and hence I am confident about that. So there are various categories which 61508 defines, wherein you can say the tool is qualified to be used in my safety system for this particular project. Yeah, coming to verification. Sorry, I am taking off from where I was doing a similar presentation yesterday. So these are two of the checklists which I have picked from a sample project. So the requirement is done, the design is done, the coding is done, and I am about to be doing the testing. Somewhere in the chain of activities, a V&V team member has been given a checklist. So here is the product and here is the checklist to either test it or verify that. So go ahead and read and then do the activity accordingly. Are there test cases to present to the systems, events to system in random order and random frequency, and also at definite points of time and in different and wrong sequences. The V&V person is lost straight away. What is that for a nuclear reactor, maybe for an aircraft or for an automotive system? What is that he is supposed to do as part of this? Take the second question again. Are there tests to check concurrency issues, invoking different interrupts at the same instance, invoking interrupts consecutively with different order, different chain of interrupts, invoking different tasks? I am totally lost. So again the meaning here is, please understand the requirements, please understand the design, please understand the code thoroughly before you even attempt to use this checklist for verification and validation. So again the emphasis here is, a V&V person is supposed to be an independent one, but I will be a better V&V if I understand the product perspective. So that is where putting your feet in somebody else's shoes comes into picture. Let me find out what somebody else has thought for the same requirements. Obviously this is an input based on the guidelines. This checklist typically comes from the guidelines. This input has got to the designer also when he is developing the product. He is supposed to take care of this. So let me find out what he would have thought when he has seen these requirements as a guideline while developing the system. Yeah, as a activity is again straightforward. The moment you say I am supposed to do verification, go ahead and do the planning for that. and the planning means the moment somebody starts writing the requirements, I should start writing the plan for that, for how to verify the particular product. So what are the tools and techniques and strategies to be applied for verification? So there may be again various guidelines are there for planning the activities, and for each phase the verification should ensure or should basically certify that it is good to go for the next phase. When I am doing verification for requirements, my result should be telling that these requirements can be taken to the design stage. Okay, that is the expected outcome of the verification for a particular phase. Results and deviations have to be documented. If they are acceptable, go ahead. If they are not acceptable, again the existing phase people have to go back and correct on that. And yeah, document all the verification of the life cycle artifacts. Anything that gets produced as part of this phase has to be verified. It could be documents, it could be tools, it could be any other reports that are getting generated. Results are again verified. No, plan is verified, test cases are verified, test results also are verified. Okay, so every artifact of a life cycle will get verified, and similarly the data verification also. When it comes to code, data again plays a very important role. So how the data is being protected as part of the design or the requirement expectations, because your code may be fantastic, but data is getting corrupted. So my code works only on the data, so one or the other data. So how the data is protected. This is one example from table B for the performance testing. Response timing and memory constraints. So no options are given for the project team. Irrespective of the skill levels, you have to do the performance timing for test for response timings and memory constraints. Whereas for avalanche or stress testing, which means my software can handle about, let's say, 32 channels. Do you really want to flood and test that, whether it can really handle 32, or what happens on when all the 32 are talking to you simultaneously? Maybe you have an option for 1 and 2, but not for 3 and 4. So that's how you read and interpret the standards here. Yeah, there is another very important aspect which the standard is throwing. There is something called as, especially for table C, it starts detailing the rigor with which. Yeah, I am supposed to do, let's say, model based development, but what is the rigor there? Yeah, I am doing model based testing. Is it enough if you simply say I am doing, or what is the rigor? So the rigor is again detailed over here, and when it has to be done is given here. For SIL 3 and 4, or let's take SIL 4, highest rigor and highest rigor is R3, which means for SIL 1 and 2 rigor is R1, and R1 says without objective acceptance criteria, which means I can do black box testing based on judgment. I thought something, I had a feeling, and I did the testing, okay, which is okay even when the standard makes it compulsory, but I am doing with rigor 1. But the moment it is level 4, I have to apply when the SIL is level 4, and where it is HR, highly recommended, I am supposed to apply R3, which means show me all the proofs. Your gut feeling may not be enough here, or it is just not required. So that's how the standards has to be interpreted. Yeah, just one slide before. So what is not covered as part of this is what happens subsequently. So there is this is only you are doing according to the standards. It has to be followed by assessments. Okay, it could be gap analysis and then assessment, and then eventually the certification. And for some of the domains, 61508 alone may not be enough. And we have been supporting one of our customer, and he is working on again the energy, the solar PV energy project, and it's falling under this. And an additional requirement for them is the UL 1998. This is the consumer electronics standards, okay, for the programmable elements. So it's a add-on, okay, to the IEC 61508, which means they have to follow the 61508 plus the additional, or maybe some of them may be overlapping requirements from the UL 1998, and of course this for the US region. So as I said, this is for the industry, okay, and industry automation, and then some of the utilities will also require some additional standards over there. Okay, so questions probably, yeah, we will take it on the common forum.
Thank you very much, sir.
Thank you.